Hi and welcome to this clip going through question 22 from the Breadth in Chemistry from May 2016. So this first part is a straightforward empirical formula question, and I've laid out the 3 steps you need to come up with the empirical formula. Where it says to show the water of crystallization clearly, that means to include .xH2O somehow in your final formula. So by dividing the percentage by the relative atomic mass, we get the numbers in blue. So clearly the smallest number is 0.375. So that's the empirical formula we end up with, but we need to put in .xH2O somehow. So the final mark comes from showing clearly the water of crystallization as .6H2O. So if we move the page down, it gives an explanation of what happens when a student carries out an experiment to determine the amount of water of crystallization in the formula of another hydrated salt. So because this is the bottom of the page and we're going to need this section for the next part of the question, I'm going to cut this out and stick it on the next slide for you. So in the next part, the first thing you have to do is to calculate the percentage error in the mass of the water removed. So the way that you work that out is you do 2 times the maximum error divided by the reading times 100. Now because there's 2 measurements, there's the starting mass and there's the finishing mass, the error is applied twice. So if we put that into a calculator, that gives us 1.72. So the reading in this case will be the difference in the 2 masses, hence the expression in the denominator of the equation. So there's more than one thing you could possibly say for the second part. One modification the student could make to their method to reduce the percentage error in the mass of water removed. So one possibility is a greater mass of hydrated salt, and the other possibility might be using a more accurate balance. So in the final part, to try and work out whether all of the water has been removed, there's really only one thing you need to do. So at this point I need to maybe give a little bit of advice here. And that's because quite a few people lose marks because they use the wrong kind of terminology. So when you're talking about a balance, call it a balance, don't call it a scales. It's not a scale, it's not a weighing scales. And when you're talking about mass and weight are 2 different things. So this needs to be precise when you're doing these kind of wordings. So don't say weight when you mean mass, and don't say scales when you mean balance. Okay, let's go to the next and final part. So this first part is obviously mole calculation, and it lends itself to data moles equation moles answer. So you start by putting in the data you're able to work out the moles for, and that happens to be NaOH. So that gives us 3.1 times 10 to the minus 3 moles. So using the balanced equation, that gives us the stoichiometry or mole ratio of sodium hydroxide to sulfuric acid. So we simply divide 3.1 times 10 to the minus 3 divided by 2 to give you 1.55 times 10 to the minus 3 moles of sulfuric acid. Now we want the minimum volume of H2SO4. So by multiplying the number of moles of H2SO4 that we need by the number of times that 6.25 times 10 to the minus 2 goes into 1,000, in other words, because 1,000 equals the number of centimeters cubed in 1 decimeter cubed, that gives us 24.8 centimeters cubed. So now we can move the page down a bit, and you can see quite clearly it's an oxidation numbers type question. So what we'll do is make the equation a bit bigger so we can put the oxidation numbers in. So ignoring the sulfate part, because we can see clearly that that remains unchanged. So that allows us to sort of process the equation by putting in the oxidation numbers of the things that do change. Then we can work out which is oxidized and which is reduced. And the way we can deduce this is because if the oxidation number increases, you can call it an oxidation. If the oxidation number decreases, you can call it a reduction. Okay, so that takes us to the end of this short clip. Hopefully it's been reasonably useful, and as always, thanks for listening, and until next time, see you soon.